Hello, welcome back. In this video, we're going to take a look at the derivative of the log base b of x. Now, we know from earlier that the derivative of the natural log of x is just 1 over x. In this video, we're going to take the derivative of log base b of x. To do this, we are going to use one of our log properties, and that's the change of base. And we mentioned this previously in video 1. To get the change of base, it says if I have the log base b of a, I can write this as the natural log of a over the natural log of b. So to take the derivative, I can do this. I can rewrite this as the derivative with respect to x of the natural log of x over the natural log of b. Now, we have to remember, b is going to be a number. So I know that the bottom here is going to be a constant. So I can rewrite this as 1 over natural log of b. Whoops, that's a weird way to spell natural log. Natural log of b times the natural log of x. And if I were to take the derivative of that, well, remember, natural log of b is just a constant. It's like a coefficient. I can just write this as 1 over the natural log of b, and we know that the derivative of natural log of x is just 1 over x. And there's our derivative. So we're going to rewrite this. So what do we say? We say the derivative is the natural log of base, not b. Remember, this is not e here. Is going to be 1 over x times the natural log of the base. And that's our rule for the log base b of x as a derivative. So let's go ahead and find the following derivatives. Well, if I just use my rule here, log base 7 of x, our derivative, my rule would be 1 over x times the natural log of 7. Before we go on to the next example, would this work for e as well? What if I did log base e of x, which we know is a natural log of x? Well, to get the derivative, it's going to be 1 over x natural log of e. We just don't worry about the natural log of e because it's just 1. So you can even do this for any problem, really. All right, for number 2, when we take the derivative here, we would get dy dx equal to 1 over. Anytime we take the derivative of a log, we're going to get 1 over that function. Now be careful, this one does have a chain rule for us. We would get 1 over this x cubed plus x times the natural log of 10. And then we're going to multiply that by our chain rule. I'm going to use parentheses here, 3x squared plus 1. And there's your derivative right there. Don't simplify that. Oh man, this one has sin in it. So when we take the derivative here, we would get y prime equals, again, we do have a chain rule. There's my outside function. There's my inside function. Whoops. My eraser's not working too well today. There we go. So when we take that derivative, we would get 1 over the sine of t times the natural log of the base, which is 3, times the derivative of the inside. Don't forget your chain rule. Cosine of t, because if you forget it, it can cost you a lot. Moving on. Try number 4 here. Again, same thing. I could write this as the derivative as, it's a chain rule. There is my outside, and that's going to give us 1 over x squared plus 1 times, whoops, the natural log of 3 on bottom, and in the top, the derivative of the inside, or chain rule, we just get 2x. And there's our derivative. I know what you're all thinking. Mr. Warnow, how can this help me with my tangent lines? Well, let's see here. I want to find the equation of the tangent line given this function at this point. So we already got the point. The point here is 125. All we have to do is get the slope. Well, to get the slope, we need our derivative, dy dx. Well, we know how to get the derivative. This is just going to become 5x plus 2 times the natural log of 5. That was our rule from up here, right? The derivative of a to the x was a to the x natural log of a. And there's our rule right there. To get the slope, I'm going to use that fancy notation. It's the derivative, dy dx, at x equals 1. And if we plug it in, this just becomes 5 cubed natural log of 5, or 125 natural log of 5. There's my slope. So my tangent line, y minus 125 equals 125 times the natural log of 5, x minus 1. And there we go. All right, let's take a look at number 6 here. Number 6, to get our point, they gave us that, 8, 3, and we just have to get the slope. Not the stop, the slope. There we go. To get the slope, it's our derivative, dy dx, and that's my new rule. This is the 1 over x times the natural log of the base, which is 2. So my slope, I'm going to use my fancy notation. The slope is the value of the derivative at x equals 8, and this becomes 1 over 8 natural log of 2. So my tangent line, y minus 3, equal to 1 over 8 natural log of 2, x minus 8. And there's our answer. Ta-da! Alright, that's it. Hope you enjoyed the video. I will see you all tomorrow. Bye-bye.